Hello, this is Mr. Collier, and today we're doing ratios. Okay, so ratio is an ordered comparison of quantities of the same kind. So if we look at this picture here, we notice that one of the squares is purple, or whatever color that is, and the other three are white. So we could say the purple to white ratio is 1 to 3. That's how we read it, 1 to 3. Okay, that means 1 part purple, 3 parts is white. Okay, or we could say the white to purple ratio is 3 to 1. We could write like that. Or you could even say something like the purple to total ratio is 1 to 4 because 1 part is purple and the total is 4, right? Or the other way around. Okay, the next example, the purple to white ratio is, well, we count the squares, 1, 2, 3, 4, 5, 6, 7. So 7 purple. And, well, we can count all the white ones, or we know that there's 25 here in total. 25 minus 7 is 18. So the ratio of purple to white is 7 to 18. Okay, in the last example, we've got a 100 by 100 grid of squares. And it looks like there's a 5 by 5 square here, so that's 25 purple. And overall we have 100 squares, so there's 75 white ones. So the ratio of purple to white is 25 to 75. But actually you notice it's the same as the diagram right here. So it's actually the same as a 1 to 3 ratio. So you can simplify this ratio just by dividing by 25. Okay, if we divide both quantities by 25, you get a 1 to 3 ratio. That means 1 part purple, 3 parts white. Now let's look at these playing cards. The cards with faces on them, they're called face cards. Let's count the number of face cards. We got 1, 2, 3, 4, 5, 6 face cards. So the ratio of face cards to, I guess we call them regular cards, is going to be, what do we say, 6 face cards. And then we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We've got 19 regular cards. So the ratio of face cards to regular cards is 6 to 19. Okay, let's look at some more ratios. We're going to express these things as a ratio. $7 to $3. That's just 7 to 3. We could write it without units. And this one's 8 to 15. And we can check to see if we can simplify. In this case we can't because there's nothing you could divide them both by. Okay, next example, we've got kilograms and kilograms. So we can just write 6 to 5. And next example though, we have centimeters and millimeters, so you got to make sure you have the same units. This is 20 centimeters to 20 millimeters to 30 millimeters. So that's a 20 to 30 ratio. And we could divide both of them by 10. Divide by 10, divide by 10, we get a 2 to 3 ratio. Okay, next one we got milliliters and liters, so we need to change them to the same thing. We change this one to 1,000 milliliters. We have a 500 to 1,000 ratio, so we can divide them both by 500. We have a 1 to 2 ratio. Okay, next example, we're just simplifying some fractions. So just look for what we can divide these both by. We can divide them both by 4. So we get a 1 to 4 ratio. We can divide this by 5. Divide by 5 and we get a 3 to 1 ratio. We can divide this one by 7. Both numbers are divisible by 7, so we have a 3 to 7 ratio. Now with decimals, you can divide both things in the ratio by a certain number, but you can also multiply. So to get rid of these decimals, I'm going to multiply by 10, because that moves the decimal place 1, and then we don't have decimals anymore. Okay, now these two, we can look for a common divisor. That is 3, so we can divide them both by 3. And we got a 5 to 9 ratio in simplest form. Now for fractions like this, there's a couple ways we can do it. We can actually get a common denominator, or we can multiply both fractions by the common denominator. So let's do that. The common denominator would be 16. So I can multiply this side by 16 and multiply this side by 16. So over here, this just cancels and we get a 5. And over here, 16 times 3/4, we can divide by 4. And we get a 12 over here. So it's a 12 to 5 ratio.